Okay, so we are at week number 7, continuing through the Azure Data Fundamentals. This is a 3-parter all about non-relational data in Azure, with the first part being exploring the non-relational data offerings. Starting with Azure Table Storage, implements the NoSQL key value model. In here we have the data for an item is stored as a set of fields, and the item is identified by a unique key. These are scalable. They're all held in the cloud. You'll create them with a Azure Storage account. In Azure Table Storage, all the items will be rows, the fields will be the columns. Something like this. Azure Table will split the actual tables into partitions. It's a mechanism for grouping related rows based on common property or what they call a partition key. That way it's easier to search. The key in an Azure Table Storage table comprises 2 elements: a partition key that identifies the partition containing the row, and a row key that is unique to each row in the same partition. Items in the same partition are stored in row key order. If an application needs or adds a new row to the table, Azure ensures that the row is placed in the correct position in the table. It kind of does some of the work for you. This allows applications to quickly perform point queries that identify a single row, and a range query that'll fetch a contiguous block of rows in a partition. For example, like this. In a point query where an application retrieves a single row, the partition key enables Azure to quickly hone in on the correct partition, and the row key lets Azure identify the row in that partition. Having hundreds of millions of rows, it'll be very fast to retrieve data. In something like a range query, the application will search for a set of rows in a partition, specifying the start and end point of the set as row keys. Again, the query is also quick since the rows are according to requirements set earlier. The columns in a table can hold numeric, string, or binary data up to 64 kilobytes in size. A table can have to 252 columns apart from the partition and row keys. The maximum row size is 1 megabyte. We have all kinds of use cases because it's simpler to scale this kind of way. The table can hold semi-structured data. There's no need to map and maintain any complex relationships. Row insertion is fast, and data retrieval is fast. The problem, the disadvantages, our consistency needs to be given a consideration, as transactional updates across multiple entities are not guaranteed. There's no referential integrity. Any relationships between rows need to be maintained externally to the table. And it's also difficult to filter and sort on non-key data. Queries that search based on non-key fields will result in full table scans. This is great. The Azure Table Storage is great for storing terabytes of structured data capable of serving web scale applications. It's also, you can store data sets that don't require complex joins or foreign keys or store procedures. And that can be denormalized for fast access. It's also good for capturing event logging and performance monitoring data. To create and view a table in Azure, from the portal, we'll create a resource. Then we'll hit new, and a storage account, and you'll have a blob, table, file, or queue. You'll set up what you need in the field, in the appropriate fields. Then you'll hit create. While the new storage account is configured, it'll tell you your deployment is complete and you're ready to go to that resource. Then in that overview page for that resource, you'll see tables. And once in, you can click to add a new table and give it a name. Once it's been created, you can see it in the Storage Explorer. And you'll be able to add all kinds of stuff like entities into it. Something like this. You're starting to add a partition key, row keys, name and age. And then you'll see it show up. Blob storage, a different kind of storage. This is great to store massive amounts of unstructured data in the cloud. You can do block blobs, handling a set of blocks. Each block can vary in size up to 100 megabytes. A block blob can contain up to 50,000 blocks, so about 4.7 terabytes. There's also page blobs that are a collection of fixed size 512 byte pages. These are optimized to support random read and write operations. And append blobs that support append operations. These can vary in size up to 4 megabytes, with the biggest being 195. Inside Azure Storage account, you can create blobs inside of containers. These provide a convenient way of grouping related blobs together, and you can organize blobs in a hierarchy of folders, similar to files on a system. You can control who can read and write to which blob. They have 3 access tiers. You have the hot, the cool, and the archive. The hot is the default. Those are the ones that are being used frequently. The cool tier incurs reduced storage charges. It's for data that's handled or accessed infrequently. And the archive has the lowest storage cost, but has the most latency, since the data there should be retrieved only rarely. So you can create lifecycle management policies for your various blobs to go from hot to cold to archive and back. Blobs are great for serving images or documents directly to a browser. They're great for distributing files, for streaming video and audio, for a backup and restore, and analysis by any on-premises or Azure hosted service. To create one, once again from the portal, you would start at home. You'd need to go to your storage accounts. You'd select the storage account you created earlier. You would hit the overview and then select the Storage Explorer. Then you would right-click on the blob containers and create a blob container. Provided a name, of course. And then once it's made, you can begin uploading whatever kind of data, like a PDF, for example. And then it will be available for you to download and access and do whatever you want. So that is a second type. We have 2 more. The next one is file storage. This is for sharing files. Kind of your more traditional way of sharing files using SMB, the server message block protocol, like you would if it was on premises. You can do it also in the cloud. You can control access to file storage using authentication and authorization, like Active Directory. Azure File Storage is within a storage account. File storage enables you to share up to 100 terabytes of data in a single storage account. The maximum size of a file is 1 terabyte, but you can set quotas to prevent users from hitting that maximum. Once you've created a storage account, you can use things like Azure File Storage or tools such as AZ Copy to upload and download files or to synchronize between the on-premise and cloud. To create this kind of storage from the Azure portal, you'll go into your storage account, you'll hit Overview, and create a new file share under Storage Explorer. You'll give it a name. Once it's made, you can begin to upload files as you want, and then they'll be available. The last of the non-relational data offerings is Cosmos Database, the multi-model NoSQL database management system. Cosmos Database manages data as a partitioned set of documents. A document is a collection of fields identified by a key. The fields in each document can vary, and a field can contain child documents. Many document databases will use JSON to represent the document structure. A document can hold up to 2 megabytes of data, including small binary objects. If you need to store larger blobs as part of a document, use the Azure Blob. Cosmos Database provides an API to access documents using SQL-based type of connections. And you have various APIs like SQL API, Table API, Mongo, Cassandra, and Gremlin. Different ways to communicate and work with the data there. You can also take documents in a Cosmos database and organize them into containers. They'll be grouped together into partitions. Partitions hold a set of documents that share a common partition key. Similar to the first one, where you can tie in various documents together by partition keys. This is great for things like IoT and telematics, for retail and marketing, for gaming, and web and mobile applications. With that, we'll move into the second section of provisioning and deploying non-relational data services in Azure. A Cosmos database account can be provisioned through the through command line. You could use the Azure CLI or PowerShell to provision a Cosmos database account. Databases and containers can also be provisioned the same way through the CLI or PowerShell, which does become the faster way than going through the portal. Now, so here is creating a storage account from the Azure portal, and then you also have the CLI way of doing it. If you wanted to provision data lake storage in a storage account, you could do it through the portal. And there's the specific area where you would enable the data lake. Then you could go into containers and see your data lake storage. You could also do it in the CLI and in PowerShell. Your blob storage can be provisioned. Again, we're going to keep doing this. You can do it either the GUI way and follow the process of creating a container, or you could do it faster by just doing it through the CLI or PowerShell. File storage, same thing. We have our storage account. We go under overview. You can create a file share, or you could just spin it up command line. You can restrict connectivity by using the firewalls and virtual networks. This image shows you the Azure Storage account, and most of them will have similar ways of getting that for other accounts. You could use things like the Azure Private Endpoint. You could also use service keys that allow you to specify when you attempt to connect to the service. If you provide an incorrect key, you'll simply be denied access. This image here shows you how to find the access keys for a storage account. Under access keys, you'll see in settings on the main page, you'll see the various keys that you'll need. If a key is ever compromised, you can just click on the two arrows and make a new one. We can configure access control, which is very important since everything works off of role-based access control in Azure, and set up things like the security principal, which represents a user group or service or managed identity that is requesting the access. We can do role definitions, things like who has full access, like an owner, a contributor who can create and manage Azure resources, a reader, and a user access administrator who can access resources and basically be like a power user. You can define scopes to list a set of resources that apply to a user. When you assign a role, you can further limit the actions allowed by defining a scope, which will be helpful because you don't want to just give a blanket rights to everybody. You want to be specific as to who can access what. There are advanced security features that you can apply as well, but these do cost some money. As you see, it's a 30-day trial. Now, configuring Cosmos replication. You can have your database and containers jump across multiple regions and stay replicated. That way, everything is up to date and it is scattered throughout the world. So if anything happens, you have a copy somewhere else. By default, the region in which you create the account supports write operations. All the replicas are read-only. You can enable multi-region writes. They could cause conflict if applications running in different regions modify the same data. In this case, the most recent write will overwrite changes made earlier when data is replicated, although you can write your own code to apply a different strategy. The replication is asynchronous, so there will be a lag between a change made in one region and it becoming visible elsewhere. Cosmos can do things to help with consistency. This approach will help scalability and availability. A copy of the data will be held in each server in the cluster and ensure that the data is all the same everywhere as updates are happening. Your storage accounts that we've kind of been mentioning here and there. You have the configuration page that allow you to do some general settings, like enabling or disabling secure communications with the service, switching a tier between hot and cold, the way that an account gets replicated, enabling or disabling integration with Azure AD. There is also a section for encryption. By default, everything is automatically encrypted. The keys are handled and owned by Microsoft. You can provide your own keys if you want. There's also a section for shared access signatures to grant limited rights to resources in an Azure Storage account for a specified period of time. It'll enable applications to access resources like blobs and files without requiring that they be authenticated first. You should use this if you intend to make data public. A SAS, or the shared access signature, is a token that an application can use to connect to the resource. The application appends the token to the URL of this resource. The application can then send requests to read or write data using that URL and that token. With that, we move on to the third section, the third and last section of managing non-relational data stores in Azure. Starting with loading data using the Cosmos database data migration tool. You can use all kinds of things like JSON files, MongoDB, SQL Server, CSV, Azure Table, Amazon Dynamo, HBase, and Cosmos containers. The data migration tool is available on GitHub. It'll provide you the tools you need to process migrating data into the Cosmos database. You'll be prompted for a certain amount of information and the destination, or to populate into a container you already have or make a new one. You can configure Cosmos database to support bulk loading if you have a large amount of data coming in. You can have it batch data into chunks and load those chunks in parallel. If you already have a container, you can use the scale function to grow it for a moment while you scale up, while you get tons of information in. And then once it's all in, then you could use autoscale to go back down. Once we have that data up, then we can use SQL-like queries against Cosmos database. You can do simple things like standard SQL commands. You can also use the Data Explorer, which I'm showing you here, where you could make a new SQL query. Even though this information is a NoSQL, you can use SQL to go through it, enter in whatever you want to search for, and then execute query to get your result. And then later you can view history of prior queries and see the results and interact with it that way, allowing you to also like create new items, update, upload, and so on. Blob storage. Oh, look at that. I forgot to make that active. You can get it through the Azure portal under containers. Now you can add a new one and give it a name, or of course you can manage it completely from the command line or PowerShell. Uploading to Azure Storage again, piece of cake. Create an image. Oh, that's horrible. The image is right in front of that. But you understand that you have your containers. Within the containers, you can upload, or you could do it all command line. If you want to list the things in a container, once again, not surprisingly, you can do it both command line or through the portal. Which is great because you can script a lot of this to create, to download, to upload, and so on. Not surprisingly, doing things like creating file shares. There's deleting a blob. You can delete a single file or do it all together. You can delete an entire container in the same way, either through the portal or through the command. Creating the file shares, like we said, easy to do in the portal, easier to do in the command line. You can use the Storage Explorer to look at the things you have made up in the cloud and upload, download, do whatever you need. You can even mount it if it's out in the cloud and you want to mount it locally in Windows. You can totally do that through your Storage Explorer. That SAS token that I mentioned earlier works with the AZ copy tool, where let's say you had some Linux VMs with information that you want to upload. Well, that's where the SAS token would come into play. And then you could use AZ copy to upload information to Azure through Linux. Very easy to use. Just fill in the information where necessary, and you're off. And just like that, we got through another section. Any questions? Okay, I see no questions anywhere. So I updated, if you didn't see Discord, I updated the skill submission so that all you need to do is submit a website URL. So if you have your video all done, just put the website URL of that video in there, and then that's it. And I have fixed that for the entire class. So all 4 skill submissions now accept URLs only. So if you've sent me the URL before, just put it into Canvas. That way it's there on record. Okay, seeing no other questions, I will end the stream and stop the recording.